Hello, my name is Michael. I'm a data editor at PANGAEA, and today I will show you how to prepare and curate your data before you submit them to PANGAEA. So why is it so important to prepare your data well? So one major reason is that you want your data to be reused by others in the future, by other researchers and other stakeholders who are interested in your data. If you prepare your data well, then it will be much easier for other users to understand and to actually use your data. And this in turn will mean that your data will be cited and your research will be cited and your general research will have much more impact. The second reason is that once you submit your data to PANGAEA, we data editors will actually review your data. And this process will be much shorter if you curated and prepared your data very well, which at the end will mean your data will be published much faster. So there are many different ways how to curate and prepare your data. Some may use a regular spreadsheet program, some others use a scripting language, which they normally use for their data analysis. In today's example, we will use Python, and for this I prepared a data curation checklist in Jupyter Notebook, and I will show you how to do this.
So the first thing we do is we go to GitHub, and in the search box we enter PANGAEA Community Workshop. And there we find our repository for our community workshop material. We click on that. There we can see a couple of files and folders. We want to go to the Python folder. And in this folder, we can see another folder called Data Curation Checklist. So we go in there as well. And there we can find the data curation checklist Jupyter Notebook. So there's different ways how we can execute that and use that. So one way we can download the file and open it locally on our PC. Or we go to the bottom of this page. There you can see a link to my binder or a link to Google Colab where you can open the notebook by directly clicking on either of those. So for the demonstration, I will use Google Colab. However, you need a Gmail account for that. If you do not have that, you can also just click on the My Binder badge. Otherwise, you just click on Google Colab. So once you've done that, you open the Jupyter Notebook, in this case in Colab. On the left side, you can see the different chapters of the checklist. You can quickly scan through that to see what the contents are. And the next step would be that I walk you through each of the different steps in this checklist. So this data curation checklist contains a lot of things which we as data editors encounter during our everyday work. So lots of issues we have with the data we got submitted to PANGAEA, and the idea was that we include those things and those supportive code to help you in advance to curate your data before you actually submit it to us. First, we start with just reading the general information. You can see we actually have a version number. So this document is a work in progress. So we're going to keep updating the content of this checklist via GitHub. You're also invited to actually fork the repository and suggest your own code and your own data curation tweaks. So please do that. We are more than happy to receive this and include this in our data curation checklist. So on the info box, you can see a couple of links. One is about the instructions. When you click on that, you will be directed to our wiki pages, which are very extensive. So we have a couple of information on our wiki. In this particular case, we have information about the data submission. So a couple of information and recommendations and requirements as well about how and which format you have to submit data to PANGAEA. So please have a careful read through all these instructions and information, because that will significantly help us to really improve the data submission. Another link will go to our data templates. So we have a couple of best practice manuals and templates also on our wiki for different domains. So you can also click here on biological data. And if you scroll down, you can see links, download links for different kinds of templates. We have templates for field observations. We also have specific templates for field experiments as well as laboratory experiments. So please use those templates, paste your data in those templates before you upload them to PANGAEA. So back on our data curation checklist, we can scroll down. First part will be just about importing our libraries. We have some specialist libraries such as the Letlon 23 library, which is for converting latitude and longitude. So we press on the play button here on Google Colab. Get a short warning because it wasn't done by Google. Ignore that and load the libraries. Please note that we get an error warning when you do this for the first time because we have to install this special library first. So we delete the hashtag and actually pip install the Letlon library. So you can see it's installing right now. It takes a short while when you do this for the first time. It worked. Then you can put the hashtag back, load everything again, and then it should work. So then we come to the second chapter where we simply create a practice data table which contains a couple of issues and errors which occur very frequently during our work at PANGAEA. So errors that very likely also occur in your own data and which would need to be fixed before submitting them to PANGAEA or any other data repository. So have a look what errors can actually happen. That's already quite a good guide to see what can go wrong. You execute the cell to create the data frame. And here you can see the data frame. You can already spot a few issues. And that's it for now. The next chapter will be the actual data curation, where we first check the general data structure. So some really basic rules, what you should pay attention to. So one rule would be one entry per cell. So do not squeeze multiple values or text entries in a single cell. The second part would be that each column corresponds to one feature, one variable or parameter. Next one would be that each row represents a single observation. Very important is also we have a single header row, especially when you work in Excel. It's very tempting to have very complex headers, 2-3 rows of headers with merged and wrapped cells. Please do not do that. So we really just have a very simple single header. As well as don't mix numeric values and strings. The first thing we do is we have a look at our general structure of the data frame. So we execute the simple command by looking at the top and the bottom rows of our data table. You can already see a couple of issues. So for instance, we have not a single header. We actually have something in the second row which are not observations. We have funny NA values here. We have a comma and dot decimals mixed. We have not an appropriate format for the geolocation and quite a couple of things by just having a simple glance at the general data table. Now we actually start fixing those issues. So we remove, for instance, the first row which contained comments, but you saw we also have some text entries in the numeric columns, which indicates aggregated values which you don't want to have in a data frame. So we delete these two rows and are left with only observations in those rows. Next thing we do is we want to check the different data types. So do we actually have the data that we expect, or does Python or any other program actually recognize those data as the intended ones? And for this you can use the dfinfo command in Python, which gives us a very quick overview of the data types in the last column here. And here, for instance, you can see that water depth in centimeters should be a numeric value. Latitude and longitude should actually be in float. So you can already see by just getting this information about the data type that there must be some issues in our data frame. And there are a couple of ways to fix those issues. So we just have a short look again at our first rows of our data frame. To inform us about what we actually have to do. So we see we want to work on, for instance, those commas. We want to work on these odd missing values. And first of all, we start by removing all columns that contain nothing. So very often, especially when we work in Excel, we may have some columns that look empty, but once you actually load them in Python, they are considered a valid column for whatever reason. So there must have been some values entered at some point, maybe a small sign left which we forgot to delete. They are recognized as proper data, and we want to make sure we delete those with a simple drop NA command. The next part will be to remove those ambiguous missing values. So sometimes you get values like that, which can be generated from your measurement device. Sometimes we also get something like that. In PANGAEA, at least, we simply want empty cells for missing values, nothing else. So we execute that, and once, for instance, you have a look again at the data head, you can see that we remove those missing values. Then the next step would be to check for comma separated values. So I said we have a US style of decimals, and we want to remove any commas and replace them with dots. So first of all, you check again how this looks. So for instance here, as I said, we have a comma, but we actually need a dot. So we have the simple function here, which we put into the checklist, which replaces the comma with a dot. So we just simply do that. And once we have a look again, we can see that the comma is gone. The next part would be to convert everything else to numeric. So we can force the data into numeric data format with this pd.toNumeric command, which we use from the pandas library. So we select those which are relevant. And we can see already that we could convert columns which are previously recognized as object now to numeric, or in this case float, data types. After this, we focus more on the text-based cell entries, which often have leading and trailing white spaces, which we cannot spot in Excel, or it's really hard to spot in Excel. And with this command, we can automatically remove any leading and trailing white space in the whole data column, or at least for all object-based data type columns in the whole data frame. So we execute that, and then all the leading and trailing white spaces are removed. So the next one is quite important for PANGAEA, which focuses on the date formatting. So PANGAEA, but also many other data repositories, have a specific format requirement for the date time. And PANGAEA follows the ISO format, which starts with a year and 4 digits, then the month, and then the day. And then with the T between between the date and the time to basically indicate the beginning of the time, and then hour, minute, and seconds. All this, very important, should be in UTC time. So I know normally when you record your experiments, you would just record your current time, but in PANGAEA we expect that we have the time provided in UTC. So please pay attention to that. That's very important. You can also provide both times, so you can have a time for the experiment, the current time, and in addition to that, you can also have the time provided in UTC format. So what was the issue with our time and date? So we can just have a short look at this again. So we saw that in this data table, we actually have date and time separate. So remember, we want to have the date and time united in one single entry. So we have to join both of them, which we do with this command here. So we join the two columns into one, which you can just call df date. And after this, we use the strift time command from the Python library to convert this into our final PANGAEA ISO format for the date. After this, we do no longer require the time column and just will delete that. So, and now we have one single date time column, which corresponds to the required format. The next step would be to convert our geolocation, so the latitude and longitude, from degrees to decimal format. So in PANGAEA, we do not work with this kind of format. We want to have our geolocations in decimal format. So here, just one short note. So once we have the decimal degree format, we want to pay attention that we also have negative values, and this means that south and west are indicated with negative signs. And we also use the WGS84 projection for our geolocation. How do we do this? You could see that here the latitude and longitude in this data frame are actually joined in a single cell, which violates one of our clean data rules, I would say, where we want to have only one entry per cell. So we don't want to see that, of course, so we have to find a way to separate that. And in Python, we have this very convenient command called split, where we can basically select a separator and then split those values up in a list comprehension command. So we basically then create a separate column for latitude and another column for longitude. And after that, we just remove the old column and delete that. And we end up with having these values separated, not in the final format we want to have right now, but we already simply separated that into two different columns. Now we would come to the final task of converting this to decimal. So here we have a very convenient function which is using that lon library, which you remember me from the beginning, from the import, which we had to install separately. We wrap this whole thing in a function, and what it does basically is it picks up in this format here. We can define exactly how this format looks like to convert this into decimal. So we execute this command, and voila, here we see the conversion into decimal. The next thing we're going to work on is the spelling, so in particular the abbreviations. So we had one column called threatened status, which contained a couple of abbreviations. And here it's important to understand that we want to make sure that our data table is easy to understand. And any abbreviation in our data table will make it harder for the users in the future to understand and decipher the meaning of your data. So right from the start, please make sure to avoid abbreviations. It is always possible to abbreviate later on for the users later on, but you as a data provider should have no abbreviations in the data table. For this, we have another command. So first we just look at, okay, what are the actual abbreviations? So I can just execute this in a separate cell. So here we see we have 4 different types of abbreviations. So we can copy and paste that into our tuple here at the bottom to save that. Just delete that. And we have another variable called spelled out, which basically saves the translations for the abbreviation. So you can use that to then use the replace command to replace all these abbreviations with the spelled out terms. And you can see, instead of having the abbreviations, we have very clear, easy to understand terms. So you may have also noticed that we have a species column which contains lots of different species names. So what we experience as data editors very often is that there is almost certainly a spelling mistakes in species names. So it gets very tedious if you have hundreds of different kinds of species names in your data table. And for this reason, we have another function to correct the species names, where we actually cross-check with different databases, so worms for marine species and itis for species in general, to cross-check the spelling of those species names. For this, we first extract those species names and save them in a data table. Very important is to just give it a simple parameter name, so actually name, as this has an impact on how the databases, the worms and itis databases read in this text file. So it basically creates a text file, which you can see in our file. So you can see here we saved the text file with our species names, unique names, so we don't have duplicates in there. That's why we had this command in there. And following this, we go to one of those databases. So I can choose to either use worms or itis to cross-check your species names. Before we do that, we actually download our species file. I've already done that before, so it is all right. I often prefer itis because it checks for marine as well as terrestrial species. So it's a bit broader in terms of its scanning, but it may not have as many specialized entries as worms for marine species. But for this example, I will just use itis, so we click on that. There we have the choosing file button, which you click on and upload our file. Then we press upload, worked. And then we go to next. And to see if it worked, we can already have a preview of our data file. We can see, okay, it read in the data properly. We have the species names listed, got recognized properly. Then we can select a couple of options. So yes, we are dealing with animals in this case. And we want to compare this to scientific names. So we want to check if our scientific names are correct. And then we just click on taxon compare. And whatever was found and matched in the database will be listed in the first section, where you can see the TSN number, so the unique identifier for this particular species. Whatever was not found is listed in the second part of the table, which will already give us a hint for spelling mistakes. So in most cases where species are not found, it's due to spelling mistakes. Then we can also download the results. We can download that, save it on the desktop, and can check out the file later on as well. Once we found our spelling mistakes, we can correct this by using a simple replace function. So in this case, it was our dolphin, which was spelled incorrectly. So we fixed that. Now it's correct. And this way we corrected all our spelling mistakes. The next step would be to check out our parameters, so the header names for each column. We want to be sure that they are clear and very descriptive and do not contain cryptic abbreviations. So it happens very often when we see data frames at PANGAEA that they contain abbreviations like that. So WCS. So no one would know what this means. Even experts probably wouldn't know what that means. So please avoid that and instead always spell out the parameters. So in this case, it would be water content sediment. Make sure that the parameters are all in English and that the parameters come with a unit. So it sounds obvious, but very often we also get data sets that do not come with a unit after the parameter. So please make sure you have that. In PANGAEA, we have a convention of enclosing our units in brackets. So we can also do that. We have some specific PANGAEA conventions in terms of writing units, such in this case for square meters. We use these 2 stars. And furthermore, you can also find parameters in our PANGAEA database. So we can simply go to PANGAEA. In our website, you can search for datasets which are very similar to yours and see what common parameters are used there and try to match that to your own dataset. We also have a specific parameter database which you can download as a text file, which has about more than 200,000 parameters, where you can also find suitable parameters. But to make things a bit easier, you can also just use this code where we basically harvest this list from the web using the request command and the request get command from Python. So we can simply download that. It just takes a second and it should pop up in our list. Let's have a look again. Yeah, so here we have the parameter table. And then you can use that to actually scan for certain parameters. So in this case, we just have a short look how the list looks like. So it has currently 204,000 parameters. So quite a bit. You can see in the first column all the different parameters are there. And then below that, we have some other functions to quickly scan through the parameters to find the one you need. So for instance, if you look for latitude, we can look it up. And you see we have lots of different types of latitude parameters. So just have a look which one would be most suitable for your particular data set. And if you're not sure how it's spelled, or you just want to find a parameter which is very similar, you can also use this getCloseMatch function. So this function does not look for an exact match, but it looks for similar matches. So you execute that, and you see the result is slightly different. So this way you have 2 different functions to find potentially matching parameters for your dataset. And once you found the right ones, you can simply replace the parameters in your dataset with this command. Please note here as well that in case you don't have units, for instance for date, time, or location, we still have square brackets which we add to our parameters. So the next part would be conversion, so conversion of units. Why do we need that? So at PANGAEA, we try to reduce redundancy, and one way of doing that at PANGAEA is to have a parameter which is only expressed in one standard unit. So we try to reduce the number of units. Otherwise, you would have the same parameter replicated 5, 6 times and more, just because we have different units. So we try to restrain the number of units. And for instance, in this case, for depth or water depth, we have meter as a standard unit. So in case you provided depth in centimeters, you want to convert that, which is done with this command. Then sometimes you may also have some links. So for instance, if you have some DOIs for a reference, which can be expressed as a full link as a cell entry. You can also check that. And for this, I have a small helper function to really check if those links are valid. So by executing this command, you get a feedback if the link actually works. It just queries the website, and if it returns a false, it will also let you know, and then you should correct that URL. And last but not least, we also have the very important event column. So with events at PANGAEA, we describe, for instance, a sampling location, a station number or station for a expedition. For instance, if you go on a cruise with a ship and you have a station, then the stations are often labeled, and in the event column, you want to have those labels included and named. So, for instance, in this case, we have a Polarstern cruise, which has a very defined label, and we include this in the event column. The events come with geolocation and date time, which are then later on also mapped in PANGAEA along your data set on a map. So we execute that and have now the event column. So please make sure you always have the event data, the event column provided in your data set. And once you have done all that, once your data are nicely curated and properly polished, you can simply save the data. One important note here is, so you can save as Excel or tab delimited text file. Important is that you save it as UTF-8 codec. So not at NZ, which is I think the standard for Excel. Make sure it's saved in this format. What's the reason? In case you have special characters, especially something like a German Ä or Ü or some Scandinavian letters or Czech letters, which have often different kind of characters, they will not be correctly expressed and will create errors in your text entries. So please make sure you save in this encoding format. And after you're done with that, you can submit your data to PANGAEA. I already included the link here, so I hope that all of you will always curate your data and you will get nicely prepared data for PANGAEA.